In this video, we're going to outline the typical steps required when writing chemical equations for reactions in aqueous solutions. When writing chemical equations for reactions in aqueous solutions, we are typically going to follow three major steps. 1. We will need to predict the products of a chemical reaction from a given set of reactants. 2. We are then going to have to write down an unbalanced chemical equation for the reaction in question. And then 3. Finally, we are going to have to balance the chemical equation, ensuring we have equal numbers and types of atoms on both sides of the equation. We'll look at each step in more detail, starting with step 1, predicting the products of a chemical reaction. The first thing we need to do is to identify the type of chemical reaction we are dealing with, and with practice, we will become very familiar with certain reaction types in aqueous solutions, including precipitation reactions, acid-base reactions, and redox reactions. Identifying which type of reaction we are dealing with will assist us in being able to determine the products that will be produced. Let us assume for the purpose of this exercise that we are dealing with a precipitation reaction, where an aqueous solution of lead-2 nitrate is mixed with an aqueous solution of sodium iodide. We know that precipitation reactions are a form of double displacement metathesis reactions which involve the swapping or exchange of cation and anion pairs. So in this case, the lead-2 cation will pair up with the iodide anion, and the sodium cation will pair up with the nitrate anion. This allows us to predict the products of this reaction as lead-2 iodide and sodium nitrate. At this point, however, we need to be sure we write the correct chemical formula for each product. For example, is the chemical formula for lead-2 iodide written correctly here? Is the chemical formula for lead-2 iodide PbI or PbI2 or some other ratio of lead and iodine? To work this out, in this particular case, we identify that the lead-2 cation has the chemical formula of Pb2+, with a net charge of +2. The chemical formula for the iodide ion is I-, with a net charge of -1. Clearly, these two ions cannot come together in a 1-to-1 ratio when the charge of the overall compound needs to be 0. When we do our crisscross method here, we see that the 2 from the Pb2+ ion becomes the subscript for iodine, and the invisible 1 from the iodide ion becomes the subscript for lead, giving a chemical formula for lead-2 iodide as PbI2, which we can now correctly insert into the chemical equation. It is really important to point out at this point that if you do not get the chemical formulas of the products correct at this stage, you may very well find it impossible to balance the chemical equation in the following steps. Okay, now that we have our chemical formulas correct and we have written out our unbalanced chemical equation, we can use our knowledge of the solubility rules to place appropriate subscripts for both products, whether the products formed are solids, liquids, gases, or whether they form an aqueous solution. So for example, in this case, we will place an S subscript alongside the PbI2, since our solubility rules tell us that whilst most iodide salts are soluble in water, lead-2 iodide is an exception and is actually the solid bright yellow precipitate we see formed in this image. We also use our solubility rules to place the AQ subscript alongside the sodium nitrate formula, since all group 1 metal salts and all nitrate salts are soluble in water, with no exceptions, and so sodium nitrate will always have the AQ subscript in chemical equations in aqueous solutions. Now it's time to balance the equation, and remember, all we can do to balance the equation is to place the appropriate stoichiometric coefficients in front of each substance. In this case, we will place a 2 in front of the sodium iodide and place a 2 in front of the sodium nitrate. And that gives us our final balanced equation. In summary, when writing chemical equations for reactions in aqueous solutions, we are generally going to have to 1. Predict the products of a reaction from a given set of reactants by identifying the type of reaction involved, and because we know reactions in aqueous solutions generally follow well-defined patterns, then the nature of the products formed can be readily identified. 2, we are then going to have to write down an unbalanced chemical equation for the reaction, ensuring that the chemical formulas for all substances are written correctly. We're also going to have to identify all appropriate subscripts for each substance in the chemical equation. And finally, 3, we balance the chemical equation by placing appropriate stoichiometric coefficients in front of each substance, remembering that we do not need to explicitly write the number 1 as a stoichiometric coefficient.